Okay, here we go, lesson 13. Using the Pythagorean theorem and similarity. All right, Pythagorean theorem. I found out yesterday that a lot of people don't remember the Pythagorean theorem, which is fine. It's my job to teach you. So,
Have a great Wednesday.
All right, thank you. You too.
Yeah, just trying to give us all some energy because weeks before breaks, I always feel so crazy.
Oh, for
Like
sure.
long.
For sure. Yeah. Okay, so Pythagorean theorem and similarity. Let's just rewrite Pythagorean theorem. What does it represent? It represents a squared plus b squared equals c squared. Now, the reason I used two colors for that, A and B are the legs of the right triangle. This is only right triangles, only right triangles. Now, what are right triangles? You should know that, but it's got a 90-degree angle. So only right triangles. You can never have two right angles. That would not work in a triangle. You can only have one. So you're gonna know if it's a right triangle based on this symbol right here. They put a little square in the corner to represent a 90-degree angle. All right, so it's only for right triangles. The orange represents like the 12 and the 9. So you can either go, you can interchange these two. A could be 9 and B could be 12. Or A can be 12, B can be 9. So as long as A and B are the two legs, they call them legs, A and B, C is the longest side. So C is always going to be the longest side. So in this figure, AB is the longest side of the big triangle. Longest side of the right triangle. It's also going to be the side opposite of the 90-degree angle. Okay, that's the Pythagorean theorem. So we're going to build on Pythagorean theorem and similarity. Now, let's remember, what does similarity mean? Well, usually we're talking about triangles, but it can be like any two figures. So there's two figures. Not necessarily the same size, but definitely the same shape. So you got two figures, they're the same shape. Now, the angles will be the same. I know that's a little confusing. I should have said the corresponding angles will be the same. So corresponding, that's an adjective. Angles will be the same. So corresponding angles will be the same. The sides are not necessarily the same, but they are what's called in proportion. So there is a proportional relationship between the sides. And specifically, that is, I know you're probably getting sick of my San Francisco drawings. But that's what we've been using the 49ers logo for. They're in proportion by this thing called a scale factor. So sides are in proportion by the scale factor. Okay, that's similarity. Now, there's also a technical, we'll call it the tech definition, which should be on page 357. Let's see. Similar. This is where your glossary, this is the glossary. It's huge in geometry. The glossary is huge, so important in geometry. You need to know what the words mean. So, all right, so just like it's a good segue. Here's your original figure. It's a scaled copy, so it's the same shape. So all the angles, the corresponding angles, will have the same measure, but the sides are going to be in proportion. Like this side is going to be twice as big as this side. How do I know twice? Because the scale factor is 2. This side here will be twice as big as this one. All right, so similar definition. If you want to like star, underline, circle, highlight. So one figure is similar to another if there is a sequence of rigid motions and dilations. That takes the first onto the second. So the first onto the second. So there's a so this one, it looks like they rotated. So you got that red triangle, center B, clockwise, and then they dilated it. This one would be a translation. Let's just go there to there. So we translate it, and then we dilated it bigger. So it's a sequence. That's like multiple steps, essentially. Now, it could just be one step. It could just be a dilation. But usually, there's a sequence. So like, you got to get it in the right position and then dilate it. Rigid motions are, don't forget, we did this in Unit 2, translations. Rotations and or reflections. Translations, you need a directed line segment. Rotations, you need a center, direction, degrees. Reflections, you need a line of reflection. So those are the 3 rigid motions. 1, 2, 3. 1, 2, 3. That was Unit 2, which was congruent. Unit 3, we see similarity, and that's where dilations come in. So basically we're building upon what we already know. So we already know about translations, we already know about rotations, and we already know about reflections. That's congruence. Then we add dilations, which brings us to similar figures. Now, in dilations, you need 3 things also, similar to rotations. You need a center, for your dilation. You need a scale factor, and you need something to dilate, or like a figure. So you need a figure to dilate, you need a scale factor, and you need your center. A couple good examples of real life dilations. So real life, I always like to talk about real life if I can. Think about the Batman symbol in the night sky. That's a movie. Batman, everyone knows Batman. And think about the movies, specifically movie theaters. There's a film reel that goes to the big screen. Film reel to a big screen. So they project like this film reel, which is tiny. They dilate it big onto a big screen. So movie theaters, Batman symbol, real life dilations. The Batman symbol, I actually almost bought one. You can buy one on Amazon. It's crazy. It's this tiny little device with a powerful light behind the Batman logo. If anyone can draw me the Batman logo, I'd be thrilled. Hello. Okay, back to page 92. Here we go. I think that's enough intro. So, is triangle ADC similar to triangle CDB? All right. How could I do this? Well, I like to add color. You know me. Let's go orange and blue today. Feeling an orange and blue kind of day. All right. So A, D, C. Here we go. Here's ADC. It's gonna be orange. Here is CDB. It's blue. CDB is blue. I don't know if you can see this in the video. Hopefully. There we go. A little more color. Okay, so why is the orange triangle, or is the orange triangle similar to the blue triangle? And these are the names of them. Get good with the names. It's better to say ADC and CDB. That way we can attend to what's called precision. That's mathematical practice 6. Name them with the letters. So name them with the letters. Don't forget, order matters. So, if we're going to say ADC is similar to CDB, you know that A and C will be corresponding vertices, points. D and D will be corresponding. C and B will be corresponding. So, here we go. All right. Is triangle ADC similar to triangle CDB? On this one, you could go with the sequence. That's option 1. Show the sequence of rigid transformations and dilations. That's an option. So options here. First one is the sequence of rigid transformations and dilations. That's the definition of similarity. Technical definition, page 357. Option 2 is a shortcut. That shortcut will save you time. Time is money. Time is money. Why? Because you can get paid for your time. So time is money. The shortcut is called the angle, triangle, similarity theorem. I'm going to get a highlighter for that one. The angle, triangle similarity theorem. So important in similarity. Now, this is the only one for this unit that I'm going to teach you. What the angle, triangle similarity theorem states, well, let's first see if it's here in the glossary. Because do you want to memorize all your terms? Well, to an extent. There's no chance you're going to memorize them all. But anyway, angle, triangle similarity theorem is not in the glossary, which means you're going to have to go to like your lesson summaries or maybe watch this video. So angle, triangle similarity theorem says you got two triangles. Got two triangles. Two pairs of congruent angles. So if you have two pairs of congruent angles, you can say, you can state the triangles are similar. So if you have two pairs of congruent angles in two triangles, so a total of 4 total, you can state that the triangles are similar. But they have to be pairs. You gotta have two pairs of them. All right, now we can tackle this problem. So, as you know, we have something called the triangle sum theorem. This is another big one. The triangle sum theorem. Really important. You want to add some color to that? Be my guest. Let's go with orange. Now, if you are bored in geometry, welcome to the club. It's a little dry sometimes. What I've always done, and I always encourage folks to do, is add some life to your work. I like doing these, leave a little white space. And just, use some markers, whatever. So, if you're bored in geometry, add color to your work. Also add artwork. In my opinion, if you add color and add artwork to your drawings, it's going to be more interesting to look at later. And then the concepts will stick. Okay, so triangle sum theorem, what does it mean? It means that all angles let's say the sum of all angles, and there's 3, in any triangle will always be 180 degrees. So if you add this one, and this one, they will be 180. Okay, so we're gonna figure out what this angle is right here. This one right here. We're gonna just do 2 marks. So you got the 90, that was given, and you got the 53. So here's how you could figure this angle out. You say 90 plus 53 plus, just name a letter. We can call this X if you want. Let's say, call this X, little guy right here. You can do that, it's pretty cool. It's like, kind of like coding. So 90 plus 53 plus X equals 180. Now you just gotta subtract 90, subtract 53. Do it to both sides. You will find that X equals 180 minus 90 minus 53. 37. And it's not just 37, it's 37 degrees, because we're talking about angles. 37 is right there, basically. Okay, so this one is 37. All right. Oh, there's that one. Okay. Cool. Now, you've got AB, which clearly is a line. A line also has 180 degrees. So a straight line is 180 degree, technically 180 degree angle. Because look, start at 0, you go to 180, straight line. All right. If this is 90 and the whole thing is 180, well, that's just 180 minus 90, which is 90. So that's 90. Okay. So we got a 90. I'll just write 90. We got a 90 and a 90. And we have a 37 and a 37. Huh. Wait a sec. 2 triangles. Yep. Blue and orange. ADC, CDB. 2 pairs of congruent angles. 90, that's one of them. 37 is the other. You can now state the triangles are similar. So, yes, triangle ADC is similar to triangle CDD because favorite word in geometry. There are 2 pairs of congruent angles. If you want to state them, they are the 90 and 37. Thus, by the angle, triangle similarity theorem, the 2 triangles must be similar. There it is. That's my final answer, and I'm sticking to it. No need for a lifeline. Is that game show still on the air? I don't even know. Who Wants to Be a Millionaire? There was a really good movie about that show too. So this is my final answer. Again, add some color and some life to your work. Makes it more fun. Like this could have been better. We could have drawn like Spider-Man hanging off this building. Anyway, have fun with your stuff. Okay, 13 points. Love this problem. This is a long one though. Whew. I got a meeting at 9:15, so I got 25 minutes. All right, tangled triangles. I guess I'm gonna do the cool down at the end. I kind of spaced on that. Trace the two smaller triangles onto separate pieces of tracing paper. All right, fine. Illustrative math. I'm not going to try to get creative. The two smaller triangles. Let's see, which ones are those? Well, let's just go orange. And blue again. Since it's orange and blue day. I used to have a Shark Freestyle watch that was orange and blue when I was a kid. All right, trace two smaller triangles on a separate. I'm just gonna do the same, whatever. All right. There might be a reason why they said separate. Could breaking the rules here, not following the directions. Best way to trace is to literally trace, because these images are pretty good in the book. Now, even tracing, I can't draw a straight line, so, but I do have 2 points. So here we go. Point, point. I already forgot a label, you can tell. Point, point. Put the pen on the point, then put the ruler up to the pen, then draw the line. All right, now let's not forget our labels. That was E. Is G, and that is H. Okay, I'm just gonna color this in. Awesome. Okay, so there's one. Hello. Oh, yeah. Could you just put that right here for me? Thank you very much. All right, then we gotta trace GEF. Do it over here. Why? Well, I don't know. I think I might want to leave some space, but who knows? Let's see if my ideas work. I'm sure it'll be okay if they don't. There's GEF. There's a 37-degree angle. There's a 16 that they give us, which we will probably use at some point. GE. FE. GF. Let's see what else we're doing. Did I miss anything? Just this little hash mark. And this little angle marker. Okay. All right. Now, we gotta turn your tracing paper, convince yourself all 3 triangles are similar. All right, I see why they did this. So, check this out. First one. Can you see? Got the same angle. Okay, the segments are a little bit shorter, but all the angles, oh yeah, 37, 37. We got 90, 90. This is 90 because remember, straight line. And then 90 plus 37 plus 53 will equal 180. Okay, so I'm convinced that the blue one is similar to HEF. So I'm gonna say triangle HEF is similar to triangle. And let's get the order right. So we started with, remember this is a right angle. Because straight line gives 90, that means this one's 90. Because the straight line is 180. See? Oh,
Good
there's
morning,
announcements.
Pumas, and happy Wednesday. Please pardon the interruption. This is Mr. Orona with your morning announcements, reminders, and phone trivia. Today you have periods 2, 4, and
Translate.
6 with 5-minute passing periods. Remember to get to your classes on time
Rotate.
so that you can have a strong start to each class.
H,
For
E,
general announcements,
F, H,
we
E,
have
F,
BSU
similar to
will be
E.
having a mental
G,
health and pizza
F.
event this Friday in room 303. Once again, BSU will be meeting in room
There's one.
303. Come join us to discuss how mental health is affected in the Black community while also enjoying some delicious pizza. Next, congratulations to our boys varsity team on their victory versus De Anza yesterday. Soccer season is well on its way. We want to have a special shout out for 2 special individuals in the boys varsity team.
Translate.
First is for the player of the game, Samuel Lopez. The next shout out is
Rotate.
for the freshman who played the entire game,
Reflect.
Eric Benavides. Shout out to you too. Next we have
53,
boys
53, 90,
basketball,
90.
varsity and JV is mandatory player parent meeting tomorrow after practice in the gym.
EF,
For anyone interested in playing girls volleyball next year,
triangle.
we're having an interest info meeting
H,
in Miss Castleberry's
E,
room 233 tomorrow at lunch.
1, 1.
Mr. Fisher would like you to know that chess and gaming is starting today during lunchtime, excluding Mondays. So it's every day during lunchtime, except Mondays. Stop by if you are interested in chess, video games, or just a place to eat lunch with music.
HEG.
Now for today's phone trivia. Please wait until I read the question to call extension
Nope,
410
not quite there.
with your answer. The first caller will have the chance to win the golden Puma. Once again, extension 410 will take the first caller with the correct answer.
Is it just a reflection? I think no.
This
it's
month
not.
is dedicated to honoring and recognizing the cultural traditions and history of indigenous peoples in North America
We gotta get this
as we celebrate National
87
Native
over
American
there.
Heritage
So
Month.
let's see.
Some background before I get into the question. The medicine wheel, sometimes known as a sacred hoop, has been used by generations of various Native American tribes for health and healing. The medicine wheel embodies the 4
90.
directions, all of which
37.
symbolize dimensions of health and the cycles of life. Different tribes
H,
interpret
E,
the medicine
G.
wheel differently. Some use it.
E,
Some use the 4 directions
F,
in conjunction with stages of life, seasons of the year,
Cool.
aspects of life, elements of nature, and
Okay.
the 4 directions are also connected to 4 distinct colors. What 4 colors are associated with the Native American tradition representing the 4 directions? You can call extension 410 with your answer.
Okay. So
Congratulations, Ms. Perez Franco's class, on winning the Golden Puma for the day. The correct answer are black, red, yellow, and white. With that being said, let's have a great day on purpose, everyone.
Okay, so don't forget, great day on purpose. What does that mean to me? You get to decide if you have a great day or not. It's up to you. Gotta have the right mentality. All right, Pythagorean theorem. Hey, we got a right triangle. We got two legs, 12 and 16. And we have the longest leg, which we're gonna call C. So a squared plus b squared equals c squared. So let's do an example here. The example is triangle HEF, and I'll show you why we're going to do that. 12 squared plus 16 squared equals c squared. We got to solve for this c. 144 plus 256 equals c squared. This plus this is 400 equals c squared. Got to square root both sides. Square root of c squared is just c. Square root of 400 is 20. How do you do square roots on a calculator? You go second x squared 400 equals 20. That's how you do it. Okay, so you now know that c equals 20. All right. So you got this 12, 16, and 20. Now, we know that, and this is written backwards, but this is 12, right? The long side is 12. We already confirmed the order. So we got a 12 right here. This is the corresponding side. And then it goes to 20. So, determine the scale factor for each pair of triangles. So if we're going from orange, this one, just gonna draw all the orange ones in. And all the blue ones. These are the bigger ones. Okay. So, scale factor from triangle HGE to triangle HEF will be, I'm going to do some work up here. Already determined it was 12 times your scale factor equals 20. Divide by 12, divide by 12, these are out of here. Let's take a 4 out, so 5/3. So your scale factor is 5/3 to go from this to the larger one. And how do we figure that out? Well, we've got a corresponding side, 12 and 20. 12 times your scale factor equals 20. Don't forget, A times SF equals A prime. I use the San Francisco 49ers logo on my slides. All right, scale factor from, gosh, I gotta hurry. There's never enough time. EGF to triangle HEF. EGF. Similar to that last one. We got a 16 right here. Let's do some work. 16 times your scale factor equals 20. Divide both by 16. These are out of here. Let's take a 4 out. That's 5/4. So that's blue to black. Okay, now we gotta go orange to blue. So scale factor from triangle HEG, smallest one, to triangle EFG. We'll just do this right here. We'll just create a sentence frame. So you know, we got the 12 and the 16, longest side, right? Corresponding side. So the 16 is the long side of the blue, 12 is the long side of the orange. So you could just say 12 times your scale factor equals 16, divide by 12, divide by 12. These are out of here. Let's take a 4 out, so that'll be 4/3, and that's fully simplified, so 4/3. All right, determine the lengths of HG, GF, and HF. Well, we got the 20 for HF. That's 20. Now HG. How do I find HG? Well, HG, order matters. HG will correspond to HE, which we already know. Okay, so HG times your scale factor should equal HE. HG, we don't know yet. Scale factor HGE to HEF is 5/3. HG times 5/3 equals HE, which we do know, which is 12. Ooh. Divide both by 5/3. These are out of here. 12 divided by 5 divided by 3 in parentheses equals 7.2. So HG equals 7.2. All right. GF, last one. GF. GF times your scale factor from blue to big will equal 16. How do I know that? Let's look at the order. GF times your scale factor times 5/4 will equal EF. So GF, we don't know. GF times 5/4 will equal EF, which we do know is 16. Divide both by 5/4. These are out of here. GF will equal 16 divided by 5 divided by 4. And you're going to get 12.8. Oh, tough problem. All good though, chip away at it. Watch it again if you need to. The other thing I probably would have done a little differently is just drawn the triangles visually here in the white space and then set them with the right orientation if I had that back. More tangled triangles. Convince yourself there are 3 similar triangles where you've got ADC. That's 90. So you got a 90. And then they both share A. So you can say triangle ABC. ABC is similar to triangle. Let me just think. ADC similar to ACB, right? Yeah, ACB. Why? Angle, angle. You got the angle A shared by both the big one and ADC, and then they both have the 90. All right, let's look at ABC again. It's a triangle ABC. It's going to be similar to DCB because they both have B in common. This angle right here. And they both have the 90. All right. Now you just got to figure out the last one, which is triangle ADC. Is going to be similar to so if ADC is similar to this big triangle ABC, that means this angle is the same as this because similar triangles have the same shape and all the corresponding angles are the same. So ADC will finally be similar to CDB. These are tough problems, but it's okay. There they are. Write as many equations. We're going to skip 2 and 3 for now. So lesson 13 summary is when we draw an altitude from a hypotenuse. Hypotenuse is the longest leg. Longest leg. Right triangle. We get lots of similar triangles to find missing lengths. So an altitude is a segment from one vertex to the line containing the opposite side that is perpendicular to the opposite side. Oh my gosh, so much silliness. But basically what you're gonna get is 90-degree angles, corresponding angles, and angle is the big theorem that you need to know. There's a lot that you need to know in this lesson. All right, let me try to get the cool down and then we'll wrap. I think I can do this in 2 minutes. Let's see. Find the lengths of AB, boom, boom, and BD. All right, this is just Pythagorean. So 3.2 plus 1.8 right here is 5. Then you got this 3 here. This is one of the legs of the right triangle. This is the longest side of the right triangle, and this is the other leg. So we're going to call this A, B, and C. So you're just going to say 3 squared plus B squared equals 5 squared. 9 plus B squared equals 25. B squared equals 16. Just subtract 9 to both sides. Just cancel out. B will equal 4 because the square root of B squared is B and the square root of 16 is 4. Boom. AB, 4. Now we're going to find BD. So in this triangle right here, this is going to be A, this is going to be B, and now this is going to be C, the longest side. So you're going to say 3.2 squared plus B squared equals 4 squared. 3.2 squared is, let's see, 3.2 squared equals 10.24 plus B squared equals 16. B squared equals 16 minus 10.24. B squared equals 5.76. Square both sides. B equals second x squared 5.76, enter 2.4. B equals 2.4. You got that. Then check your answers using a different method. Okay. Let's check. There's a hypotenuse. There's a hypotenuse. So we know the triangles are similar, right? We already proved that because we got angle, angle for all three. So let's compare the hypotenuses of this triangle to this. We'll just double check, okay? So AB, the length of AB over the length of the AC will equal BD, the shortest leg, of this triangle that I just shaded. Shortest leg, BD. What's the shortest leg of the big triangle? Well, you got a 4, a 3, and a 5, BC. Why am I able to do that? Well, because in similar triangles, the sides are in the same proportion. Similar word, ratio. What's a similar word to ratio? Fraction. So you can set up like a comparison of sides as long as they're corresponding in two separate triangles, and then you can set them equal to each other. Now let's just plug in AB 4, AC 5. 4 over 5 should equal BD 2.4 over BC 3. Now when you have a ratio equaling another ratio, you can just cross multiply. So 5 times 2.4, does it equal 4 times 3? Hey, 2.4 is already on the calculator, save me time. Times 5 equals 12. Does 12 equal 12? Sure does, boom. All right, that's enough for checking your answers using a different method. Not gonna make you go through another one, but anyways, there you go. Here's your cool down. This is on quiz 3. Geometry is getting harder. It keeps getting harder and harder, FYI. So, if you do not understand geometry, number one, it's not the end of the world, okay? It's not the end of the world. You're gonna be okay if you don't understand geometry. Now, there's some tips. See me. I'm available Tuesdays, 4 to 5 p.m. Tuesday through Friday at lunch. So you can come see me at lunch. So Tuesday is 4 to 5 p.m. This is after school, of course. Or Tuesday to Friday at lunch. You can come see me. What else can you do? You can watch these videos over and over. Watch videos on repeat if you need to. Remember, it's not the end of the world. If you're not understanding geometry, you're gonna be okay. So please don't stress too hard. But I do want you to get a good grade. So come see me Tuesdays 4 to 5, Tuesday to Friday at lunch. Watch the videos on a repeat. Practice. You have to do the practice problems. Like, think about how hard that lesson just was. You have to do the practice problems. Those are at the end of each lesson. If you're not doing the practice problems, all the concepts go in one ear and out the other. You're wasting time if you don't do practice problems. Now, a lot of people have to take geometry. They don't want to take geometry. A lot of people. I love geometry. I think it's cool. But there's going to be things in life that you do not want to do. So in life, there will be things you do not want to do, but you have to. Like passing geometry. That's a high school requirement. So there are going to be things that you do not want to do. My advice is to simply check in. Don't check out. Just check into those things. And what does that mean? It means try your hardest, even though you don't want to do them. Try your hardest. Like, for instance, DMV. I got to go to the DMV sometimes. Nobody likes going to the DMV for the most part, at least traditionally. I just know that I'm going to be sitting in a line for like an hour to like do some sort of paperwork that I have to do in order to drive a car. That's something that I don't want to do, but I have to do because there's laws. You know what I do? I bring games. I bring my daughter. We play cards. I make the most of what's inevitable, which is that I have to do this thing. So I encourage you, just simply check in to those things. Maximize your time on the earth. Here's what happens. If you check out of geometry, geometry's not going away. You still have to pass it. But if you check out, you make things more difficult for yourself because you're just going to have to do it again later. So trust me, do the practice problems. Watch the videos. Come see me. And don't forget, if it still doesn't click, it's not the end of the world. All right, off my high horse. Have a good day. Bye.